tangent, and you'll see in a few minutes cotangent as well. Range is all real numbers, negative infinity to positive infinity. It's going to do 2 times. The parent graph period for tangent is pi. This graph is increasing from left to right. These y values are getting bigger because they start over at a vertical asymptote that doesn't cancel out the increasing because that y value doesn't exist. And there are vertical asymptotes at the same places that cosecant's parent graph had vertical asymptotes. Negative pi over 2, positive pi over 2, 3 pi over 2, and so on. As well, it is x over y, or it's 1 over tangent, or it's cosine over sine. Whichever way works best for you is a good way for you to do this. Cotangent of 0 ends up being undefined because tangent of 0 is 0, or cosine of 0 is 1, and sine of 0 is 0. So one of these ways, eventually you see the dividing by 0, which is undefined. But cotangent of pi over 4 is still positive 1. Tangent of pi over 4 is positive 1, and 1 over 1 is 1. So that is a point they share, like sine and cosecant share some points. Tangent and cotangent share a couple of points. Cotangent of pi over 2 is 0. Tangent of pi over 2 was undefined because sine of pi over 2 is 1 and cosine of pi over 2 is 0. But cotangent is the reciprocal of tangent, so we flip that upside down, and 0 over 1 is 0. 3 pi over 4, tangent is negative 1. Reasoning similarly going into quadrant 2, and cotangent of pi is undefined. So the cotangent graph has a vertical asymptote along the y-axis, and at pi, I didn't label my x scale on the cotangent graph, sorry. I did my y scale, but not my x scale. Need to do both here, y scale and x scale. And I'm sticking with the exact same scale I chose for sine and cosine, just so that you know what they look like on the same size grid. You will get lots of various grid scales and grid sizes in your online assignments. So sometimes that will change how they look, but that doesn't change what they actually are. So cotangent of pi over 4 is 1. That's a point that tangent and cotangent would share if we drew them on the same grid. That point is the same as that tangent point right there. But then cotangent of pi over 2 is 0, and cotangent of 3 pi over 4 is negative 1. So drawing the appropriate shape between those vertical asymptotes that goes through those points gives us that rough estimate of what the cotangent graph looks like. And 1 period is generally enough, but I'm going to go ahead and fill in the grid so that you can get a better idea of what this looks like, because it does keep going on and on forever.
So you'll be 10 minutes.
2 pi with a bunch of other intervals that continue on forever. Range for cotangent is the same as tangent. That's the one nice thing about these trig graphs. That's negative infinity to positive infinity. The period for the cotangent parent graph is pi. Same as tangent for the same reasons, but these are the two that are different from all the others. So tangent and cotangent parent graphs, period is pi. The other 4 parent graph periods, 2 pi. This graph is decreasing as those S-shaped pieces are now going down from left to right. And our vertical asymptotes happen at, for example, 0 and pi and 2 pi and on and on forever. Sine, cosine, secant, and cosecant. The vertical dilation is still absolute value of A. I still can only use the word amplitude properly for sine and cosine, everything else vertical dilation. The period is the one that's different. The parent graph of tangent and cotangent is pi. So the transformed equations for tangent and cotangent will have a period of pi divided by absolute value b. So all 4 of the others, period formula is 2 pi over absolute value b, tangent and cotangent, pi over absolute value b. The range for both is negative infinity to positive infinity. Not really anything we're going to ever do to change that. The phase shift, when you're given this form with the one set of parentheses, bx plus c, instead of the 2 sets that the dual students, the AP students will only see, is c divided by b. If you do get a question, because you can get the question in the form with that b factored out with the 2 sets of parentheses or parentheses and square brackets, then that horizontal shift or phase shift is just that c number when it's given to you in that form. And only if it's given to you in that form. The vertical shift is d, and if they ask for the midline, make sure you include the y equals. And the same properties apply from before. If a is negative, then there's a reflection over the x-axis. If b is negative, there's a reflection over the y-axis.